We're facing this massive paradox in the modern enterprise right now. Our systems, our programs, our product launches, they're all getting infinitely more complex and spread out all over the globe. But our human capacity? Well, our attention spans are completely finite. We are literally hitting the ceiling of what one person can manually manage. So, what if we could just shift that burden? In today's Explainer, we're diving into the incredible evolution from basic generative AI to what industry experts are now calling digital software workers, or AI agents. We're going to unpack exactly how they tick, how developers are actually building them, and why they're an absolute game changer for enterprise scalability. Here is our quick roadmap for today. First, we'll look at what's beyond traditional generative AI, then get into the nitty-gritty of building API-driven research agents and how we can enhance their reasoning using GraphRag. After that, we'll talk about scaling all of this up via agentic frameworks, explore how agents act as actual strategic partners, and finally, wrap up with a look at the autonomous enterprise future. All right, let's jump right into Section 1, Beyond Traditional Generative AI. So think about traditional generative AI. It's fundamentally reactive, right? You give it a prompt, it generates some content, and it essentially operates in a silo. But AI agents, they are an entirely different beast. We are talking about autonomous software workers here. They actually use memory, they actively hook into external APIs and databases to get things done. They aren't just spitting out text. They're thinking, they're acting, they're learning from their own mistakes, and they are executing really complex multi-step workflows without needing a human to hold their hand the entire time. And this technological shift fundamentally changes our actual day jobs. In the old model, human workers, like program managers, are basically playing the role of historians. We wait for a delay to happen, we run damage control, and then we write a report about what went wrong. But agents, they shift us into the role of forecasters. Because they can autonomously process massive, ever-changing data streams in real time, they can spot risk signals and resource bottlenecks weeks before they become actual real-world problems. Moving on to Section 2, Building API-Driven Research Agents. So, how do technical teams actually build these things? It involves some very specific methodical configuration steps. First off, you define a clear system prompt to give the agent its overarching goal. Second, you set strict boundaries by allowing or blocking specific domains. This keeps the agent focused and, more importantly, secure. Third, and guys, this is an absolutely crucial design pattern for error recovery in long-running tasks. You have to require a JSON schema for the output. As humans, we can easily read a messy blob of text, but if you want an agent to autonomously pipe its findings into another enterprise system without breaking the whole thing, it needs that predictable structured format. Finally, you request the agent's reasoning steps so you always have an auditable trail of exactly how it made its decisions. Now, for the developers out there, these configurations translate directly into essential code parameters. You start by specifying an API-driven model, something like Flash Research, and you pass your API keys to securely hook the agent into your external databases. You apply those domain filters, like telling it, hey, only pull data from learn.microsoft.com, but the real magic happens with the max turns parameter. By setting this parameter above 3, you are explicitly giving the agent permission to perform deep, multi-hop web queries. It's going to search, evaluate the first page of results, realize it needs more context, and then autonomously fire off follow-up searches without any human intervention at all. All right, Section 3, Enhancing Reasoning with GraphRag. You have probably heard of RAG, or Retrieval Augmented Generation, which is usually done with standard vector databases. But why does standalone vector RAG sometimes completely drop the ball on complex reasoning? Well, the issue is that vector chunks are essentially just isolated blobs of numbers. If the answer to a tricky enterprise query means connecting a tiny piece of information from document A all the way over to document Z, a standalone vector search just doesn't have the structural awareness to make that multi-hop leap. This is where GraphRag steps in and completely changes the game by integrating a knowledge graph. Instead of isolated text chunks, you're working with connected entity nodes. Instead of just searching for standalone similarity, the agent performs what's called multi-hop graph traversal. It can literally trace the intricate connections between a person, a company, and a highly specific financial result across hundreds of different documents, and then pass that deeply contextualized information back to the large language model. The result? A highly accurate, deeply grounded response. And from an enterprise security standpoint, this graph structure is a massive win. It enforces incredibly fine-grained, node-based access control. You can set precise policies that dictate exactly which agents are allowed to access specific connected nodes. That means you can confidently prevent the unwarranted retrieval of sensitive financial or HR data while the agent is out there doing its autonomous queries. Which brings us to Section 4, Scaling via Agentic Frameworks. A major headache developers are facing right now is the sheer fragmentation of monolithic agent architectures. Basically, everyone is building their own proprietary frameworks and they don't talk to each other. Enter the Model Context Protocol, or MCP. This is a brilliant open standard designed to provide universal compatibility. It standardizes exactly how scalable enterprise software provides context to various large language models, coordinating multiple specialized agents across an organization. I absolutely love this analogy. The Model Context Protocol is effectively the USB-C port for AI applications. It creates this completely composable, modular design. You can literally plug and play different tools, different data sources, and different agents together seamlessly. It kills vendor lock-in and allows for some incredibly rapid experimentation for developers who are trying to build out truly scalable systems. Okay, Section 5, Agents as Strategic Partners. Let's look at how this impacts daily workflows. Let's be real for a second. For a lot of knowledge workers today, about 80% of our time is just lost to process overhead. We're constantly tracking down project updates, scheduling meetings, consolidating reports from 5 different disjointed systems. That leaves a frustratingly tiny 20% of our capacity for true, high-value strategy and proactive risk mitigation. This administrative drag is exactly what's keeping enterprises from truly scaling. But by handing that 80% over to agents, we unlock a whole new world of capabilities. Agents don't just summarize text. They act as true strategic partners. They can ingest massive, interconnected spreadsheets, analyze workload distributions across thousands of employees, and simulate complex data trends to flag resource bottlenecks way before they happen. They can model multiple scenarios, actively helping human leaders design proactive product-market strategies rather than just scrambling to react to yesterday's failures. Finally, Section 6, the autonomous enterprise future. Let's bring this all home. When you implement this effectively, the metrics are frankly staggering. Take MasterCard, for example. They integrated agentic foresight into their fraud detection systems to analyze potentially compromised cards. By allowing these agents to perceive signals across massive datasets and reason autonomously through the context, they reduced false positives by an incredible 200%. And right alongside that huge jump in accuracy, MasterCard also saw a 300% increase in the speed at which they identified merchants at risk of being compromised. I mean, that is the raw operational power of moving from reactive legacy systems to autonomous, predictive agents. It's exponentially faster, and it's significantly more accurate. There's this really powerful quote from the source material that sums it up perfectly. The program manager of the future is defined by how effectively they command their AI partner. Look, AI is not going to replace the human element. We still need that critical judgment, the navigation of complex stakeholder politics, the long-term creative vision, but it absolutely will replace those who refuse to delegate their administrative overhead to these new digital workers. Which brings us to the ultimate question I want to leave you with today. Think about your own workflows. Are you designing systems that keep your team trapped as reactive historians? Or are you ready to leverage memory, APIs, and GraphRag to build an unstoppable system of autonomous forecasters? The tools are literally right here. It is time to start building.